Hey everyone, in this tutorial we're going to cover a unique and essential data type in Python called sets. If you recall our video on lists, we mentioned that a list is an ordered collection of elements. Now imagine a collection where the order does not matter, so meaning it's an unordered collection of elements, and that means that duplicates are not allowed. So that's exactly what a set is. So to create a set, they're actually defined by curly braces. So just like dictionaries, they use these curly braces. So just because you see curly braces doesn't mean it's a dictionary or a set until you actually look at what's inside it and see if there's only commas or if there's also colons. If you see colons, it's a dictionary. So if it looks like a list that has curly braces, then it's a set. So let's create a set. Let's set this to numbers 1, 2, 3, 4, 5. So this is our first set, and it contains 5 unique integers. So what happens if we try to include duplicate elements in a set? Let's find out. So if we actually add a 1 to this, because there's another 1 in here, so you see there's 2 now, let's find out what happens. So actually originally, printing numbers would just print out the set just like this. And if we added another 1 here, and we printed it, it would still give us the same result, because sets don't have duplicate items. Of course, you could have a string containing 1, and that would be a different story. Sets are very handy when it comes to performing mathematical set operations like union, intersection, difference, and symmetric difference. The union operation combines all unique elements from 2 sets. In Python, we use the union method. So let's have a set called set1, and that's equal to 1, 2, 3. Set2 is equal to 3, 4, 5. And as you can see, there's 2 3s, so there's a 3 in this one and a 3 in this one. Now, union set is equal to set1.union set2. And if we print union set, we will get 1, 2, 3, 4, 5. The union of set1 and set2 gives us a new set that includes all unique elements from both sets. So if I had another 3 here, it would still be the same result. And in this case, the order of this doesn't even matter. We could do set1 just like this, and it would still work like that. Because like I said, the order doesn't actually matter. So if I had set2.union set1, so if I had set2 calling.union, it wouldn't do 3, 4, 5, 1, 2, because the order doesn't matter. So when you use the union method, you combine both of the sets, but only include the unique elements, because of course, sets cannot contain duplicates, and if they do, it just gets rid of the duplicate. The intersection operation retrieves the common elements from 2 sets. We use the intersection method. So we have set1 and set2, and now we can have something called intersection set is equal to set1.intersection set2. And we can print intersection set, and this would give us a set containing 3. So it's a set with 1 value, and that value is 3. And by intersection, we mean the duplicated value if these sets were combined. And if we had another duplicate like 4, we would get 3 and 4, because all intersections are added. It's not like it's just the first occurrence or anything like that, because there is no first occurrence, because sets are unordered. So when you have an intersection, it's all of the duplicated values of the set 1 and the second set. The difference operation retrieves elements present in one set but not the other. We use the difference method. So over here we can have difference set is equal to set1.difference set2. And if we print difference set, we get 1 and 2. So in this case, set1 is calling .difference, and so we're seeing the elements that are in set1 but not set2. So 1 and 2 are both in set 1, but they're not in set 2. So if we had a 6 in here, it would include 1, 2, and 6 because it's in set 1, but not set 2. And if we change this to a 4, for example, it would just be 1, 2 because 4 is in set 2. And if we reverse the order of this, it would be a completely different story. Here we get 5, because 5 is in set 2, but not set 1. All the other numbers, 3 and 4, are both in set 1, but 5 is only in set 2. The symmetric difference operation retrieves elements that are in one of the sets, but not both. In Python, we use the symmetric difference method. So for set 1 and set 2, we can have symmetric difference set equal to set1.symmetric difference set2. And we can print this, and we get 1, 2, and 5. Because the symmetric difference of set 1 and set 2 gives us a new set that includes the elements found in either set 1 or set 2, but not both. That's because 1 is in set 1 but not set 2, 2 is in set 1 but not set 2, 4 is in both of them, so it's not including that, 3 is in both of them, so it's not including that. And then moving on to the second one, both of these are also in the others, and this one's not in the others. So it's kind of like a difference method, but we're checking for both of them. So with the difference method we had before, we're only checking for one of the sets, but for this one we're checking for both. Python provides several built-in methods to manipulate sets, such as add, remove, and clear. The add method adds an element to a set, the remove method removes a specific element from a set, and the clear method removes all elements from a set. So we could have numbers equal to 1, 2, 3, and we could say numbers.add 4, and this is no kind of index or anything, we're adding 4, this could be a string, whatever. Of course there's no indices in sets because it's unordered. So we get numbers.add 4, we're going to add 4, and when we print numbers for the first time, we get 1, 2, 3, 4. Now if we do numbers.remove, we can remove any of them. Let's remove 1, so that is just the number 1, and we can print numbers. Now the first time we get 1, 2, 3, 4. The second time we removed 1, so now we get only 2, 3, 4. Now we can do numbers.clear and print numbers, and now we just get set. As we can see, we used add to add an element to the set, remove to remove an element, and clear to remove all elements. And this is just displaying set because if it showed an empty pair of curly braces, it would actually just look like a dictionary. So to separate these two, it just says set, and if you have an empty dictionary, it has the curly braces. So if you ever see empty curly braces, it's always a dictionary.